Alright, this is homework week 20, question 1. It's a jet airplane question. This week the questions were not too bad, they're fairly handy actually, but there are some more challenging ones like this, which I'll just go through and explain my reasoning for the question. So the question is essentially asking, I won't read it out, but it's essentially asking to calculate the intensity or the strength of a wave, I guess, as it expands a certain amount. And initially we're given information that the strength of the wave or intensity at 5.3 meters is 100 watts per meter squared, and then we're asked to calculate the intensity at 120 meters away from the plane, as demonstrated here, as the wave expands. Now, the way I'd think of this question would be to sort of compare it to blowing up a balloon. So if you imagine a balloon, it has a rubber of certain thickness, but if you blow into the balloon expands, and the rubber gets thinner and thinner, and that's the way I would think of this question. So there's a certain amount of energy or rubber in the balloon, and then as you blow it up, the amount of rubber or energy in this question does not decrease, but rather it just thins out, diminishes slowly, and that's the idea of this question as well. Patients I came up with. So I thought it was the radius was 3 for a small sphere at first for some reason, but it's 5.3, so that cost me a bit of time wondering why I was keep getting it wrong. So anyway, we want to compare how much the energy is diminished from the small sphere to the large sphere, and the energy is, if you imagine it like the balloon once again, on the surface, and the surface expands. So you want to find out by how much or by what sort of factor the surface has expanded. So the way I done that was I just simply put the radius into area of a sphere for both of these. I got two values. These are the surface area of a sphere for each case, the small sphere and the large sphere, and then I compared the two areas just by dividing, and I got this number. Now this number, the way I describe it anyway, would be sort of a ratio from, well, it is a ratio of how. Alright, so that was the shittest explanation you're never going to hear, so I'll just redo it. So this number right here, you can imagine it sort of as an expansion ratio between the large and small sphere. If the large sphere was 1, and then the small sphere would be 1.95 times 10 to minus 3. So given we have the expansion area for surface area, and the power of a wave, as it diminishes, is proportional to the surface area of the sort of new area it occupies, you can also apply that to the energy. So the sphere diminishes by this amount, and so does the energy, because the energy is proportional to the surface area. So then you just multiply it by 100, which is the amount of watts or power on the sphere it has initially, and that just gets you the answer. Alright, question 2 is pretty self-explanatory. It's just what is the speed of waves whose frequency and wavelength are 412 hertz and half a meter respectively. So there's a formula for this. You put numbers in, you get a value. Or if you don't remember the formula, you can just think, well, the wave is half a meter. It happens every 412. It happens 412 times a second. So if something passes by 412 times a second and has half a meter in length, then that whole sort of thing would be 206 meters. That's question 2. Question 3 is fairly straightforward. You just look at the graph, and the amplitude of the wave is 2.5. Simply, that's it. So for question 4, you simply just measure the wavelength. So I don't know, you can start here and there, go there and there. But simply enough, you just measured wavelength, which I just measured. I counted each little segment individually, so on, and I got 14 meters, which is the answer. Question 5 is not too complicated either. It's just we're looking at the graph. The graph has shifted over a bit, and it's shifted over in 1/10 of a second, and in that time it shifted over 2 meters. So you could say that in 1/10 of a second the shift is 2 meters, so therefore in 1 second it's just 20 meters. Already calculated the things we require for it. So it's asking us to find the frequency of the wave. There's a formula for that, and we've already calculated velocity and the wavelength, so you can just put it in and get 1.42, and the frequencies, of course, hertz. So don't forget hertz, because you might get, like me, because you might get marked down.